So we all know what it sounds like when a car passes by us blowing its horn. But did you know that what you just heard was the Doppler effect? The sound coming towards me has a shorter wavelength and a higher frequency, while the departing sound has a longer wavelength and a lower frequency. As the car approached, the frequency of the pitch increased. As the car went away from us, the frequency decreased. Sound waves consist of high-pressure zones, compressions or peaks, and low-pressure zones, rarefactions or troughs, that are repeated over and over again. When a car's horn makes a sound, it vibrates the air, which vibrates your eardrum. If that car is stationary, the distance between any two peaks or troughs in the wavelength of that sound is equal. But when the car is moving, the wavelengths of that horn sound become shorter as it approaches and longer as it departs because of the location where the sound is produced. Since the speed of sound does not change, even a small change in distance can cause a different pitch. The Doppler effect is our perception of the difference in frequencies. The same thing happens with light waves and can be seen in space. Rather than changing the pitch, though, what changes is the color that we perceive and the object that is moving towards or away from us. As objects like planets or even galaxies move towards us, the wavelength of the light compresses, making it appear blue, a phenomenon we call blue shifting. And on the other hand, objects that are moving away from us will appear red, or red shifted, as the wavelength of the light is stretched. Andromeda, our nearest galaxy to us, is actually traveling towards us at about 300 kilometers per second, making it appear blue. And I hope that next time you hear a car pass, you'll think about the Doppler effect and how it affects your perception of the everyday world.